So today our second lesson, second lecture, and we will go in our next lectures through the key building blocks of DeFi. And the first building block and the key one, the cornerstone of DeFi is, of course, stablecoins. So what is stablecoins? Stablecoins, generally speaking, are a class of digital assets pegged to a certain benchmark, such as fiat currencies, digital currencies, precious metals, some inflation index, whatever. So it means that stablecoin is not only something pegged to US dollar, but it might be pegged to euro, it might be pegged to gold, silver, and even inflation index, as I just mentioned. The first stable coin on the market, and now it's the biggest one, the leader of the market is USDT. The T is the name of the company, it's the Tether, and the project was launched in 2014, and so far actually it kept back to the US dollar, but it was in history that it was unpacked by 5 to 8 cents. Coming back to the market share, to the market cap of stable coins and how much do we have the stable coins now, is that today the market capitalization is more than 150 billions US dollars, 30 billion dollars. And you see here the red line, that's the market capitalization, and the blue one, that's the total value locked. And what we also see here is that the blue line was over the red one, but after the Luna stablecoin collapse, Terra Luna stablecoin collapse, the total value lock decreased and the market cap also decreased, but not so far. How would it happen? So again, red line is the market capitalization. So it's simply how many stable coins do we have in ecosystem on blockchains. It's 130 billion dollars. But the blue line is total value locked in DeFi protocols. As we spoke before, what are the stable, actually the protocols, DeFi protocols? It's when you put into the smart contract one token, get another, go this token to another smart contract, put it into that smart contract, receive another, and it goes over and over. So if we have $100 market cap, we can turn it into 244 TVL. How? Simply by actually using lending protocol, putting this $100 US into lending protocol, taking $80, then putting this $80 into the same protocol, taking 64, and doing it once more time. So in total, as a result, you get 244. Well, it sounds like nonsense, no reason for doing this, but in reality, it makes sense. It makes perfect sense when you can, let's say, target some interest rate arbitrage on different lending protocols and actually earn money by making this type of loops of investing, taking loan, investing, taking loan, depositing, taking loan, and doing it a few times. So what are the stable coins rating? Actually, here we have top 10 stable coins, and the top 3 positions are taken by so-called fiat-backed stable coins. We will talk about it right now. So it's USDT with the market cap of 81 million US dollars, USDC, 30 million in BUSD, only 6 billion. And the first and the largest crypto-backed stablecoin DAI is only have up to $5 billion, no more. And also we have very interesting stablecoin Frax, that's 1 billion. Here you have what I just said. USDT at some time in the past had these problems with the peg. So it's in 2017, it costed even less than 90 cents per one USDT. And now that could be a disaster, but in a recent, maybe it was a month ago or 2 months ago when USDC lost back to 92, 93 cents for $1. And I will explain why it happened later and why to some stable coins this type of stuff can happen, and for some cannot. So how do we generally classify our stable coins? So we have on one, let's say, dimension, over collateralized stable coins and under collateralized stable coins. And on the other axis, we have centralized issuer and decentralized issuer. So USDT and USDC are actually centralized stable coins with centralized issuer, which have one-to-one backing. What it is, I will explain a little bit later. And on the other side of this axis, we have decentralized stable coins, DAI, for example, SUSD and FRAX. It means that this system is built on smart contracts, but each of the system have specific, let's say, properties, and they are different. And in terms of collateralization, we see that only FRAX is a little bit under collateralized, and DAI USDC is over collateralized, while centralized stable coins, they're almost one-to-one. And if we talk about Luna, which got burst actually a year ago, it was deeply under collateralized. Centralized issuer, how does this model work? So what it means? It means that actually, as soon as our centralized issuer issued a stable coin, a token. So stable coin is a simple token. For the Ethereum, it's ERC20 standard, but with some specific, let's say, additional features and functions like blocking, for example, because USDC and USDT stable coins as a tokens, they might be, and actually they have been blocked for specific addresses which reported involved in some fraud or crimes. And for each issued USDT, USDC, or USDP, and lots of other centralized tokens, we have actually $1 value in bank account. That's the real dollar in bank account, and not maybe real, maybe some US treasuries, but we can say that it's equal to the US dollar. And yes, if we look at Tether reserves, we see that 82% of assets are cash and cash equivalents. The rest are also very liquid commercial papers, bank deposits, and other stuff. But we can say that for 100%, each of USDT token has a real solid US dollar backing. How do we know this? And actually, how the centralized issuers are confirming that they have these assets? They actually go to independent auditor, and auditor issues one time in a year, one time in a quarter, or a monthly report. And the report says that, yes, we actually, as an independent auditor with a license, looked at the real reserves of the issuer, and we confirmed that they have this money on banking accounts. And yes, each issued token is actually backed by, secured by these assets. What are the pros and cons for centralized stable coins? On the actually good side, I would say the pros is that it's simple. So simple technical implementation. If I have a license, I can issue my own stable coin, centralized one. If I'm a company, how I should just issue a token on blockchain, and on the other side, I have to confirm with the audit, with the independent audit, that I have this money on a bank account, and that's it. These companies are also regulated by government authorities in specific jurisdictions accordingly. So, and you're also regulated, because you cannot, I think, issue it in any country. You need to have a license. On the con side is that centralization and dependence on one issuing company. What it means is that if something happens to the company, there will be problems with the stable coin immediately. And it happened with BUSD, but there was not some DPEG, but authorities, US authorities, as far as I remember, applied to BUSD issuer, Paxos, I think, and they ordered them to actually, they have that you cannot issue more, and actually for the few months recent, the market cap of BUSD decreased by $10 billion. It means that lots of actually tokens were exchanged for the real US dollars. And of course, the risk of banking partners the risk of banking partners bankruptcy. And we know a specific example with this Silicon Valley Bank, when Silicon Valley Bank lost actually ability to pay, and USDC admitted that they have a few billion dollars backing with the bank, and immediately it was, as far as I remember, on Saturday, one of the Saturdays, the USDC lost its peg. Of course, it's non-transparency and inability to directly verify reserve, so you cannot do it on chain. You should trust to some audit, and of course, this possibility of blocking of any addresses with tokens by the state authorities' requests. And it happens then hundreds of addresses, not too much, taking into account the volumes and the number of issued tokens and the market cap, but still any account holding USDC, USDT, any centralized issued token could be blocked. That's what happened to the USDC. 3 billion USDC reserves deposited in Silicon Valley Bank was actually treated as lost for some period of time. But as soon as US government tell that any bank deposit from Silicon Valley Bank will be returned to the owner, USDC restores its peg. So I myself, looking at what was happening, immediately calculated this 3 billions blocked in Silicon Valley Bank, and understood that taking into account the market capitalization of USDC, it was about 7% at that time. So I actually calculated that USDC cannot go lower than 93 cents. So that's what specifically happened. Everyone has done the same math, and we see that the lowest level of USDC was about 93 cents. Then it's restored its peg. Now, that was the simplest actually part of the lecture. Let's go to the complex one. So the complex one is how the centralized issuance work. And we start with the example of the DAI. And we should here understand the so-called CDP concept. What is CDP? It's collateralized debt position. Simply speaking, it's a smart contract. And this smart contract is doing the very simple thing. So it accepts from one side the collateral, and it allows you with until the specific the sum set collateralization ratio, issue the stable coin, another asset. So you put one asset and with a specific ratio get another. And one more function of this collateralized debt position is that your position could be liquidated. It means that if this actually amount of collateral of the tokens you provided will go, the value of this collateral go below a specific threshold, any third party can repay your debt and get this collateral with discount and receive this collateral with discount. This is the chart of how it works. We have CDP, that's smart contract, and our collateralization ratio is 150%. Let's suppose we have a collateral of Ethereum, and we put $3 value of Ethereum into our CDP, and then get just $1 of our stable coin DAI from this CDP. What happens is actually CDP is printing this stable coin to us. So before that, this one DAI, which is equal to $1, did not exist. So we are the issuer. We are like the central bank here. So we are who initiates the issuance of this stable coin. And then we have collateralization ratio is 300%. And what happens when, for example, the value of our Ethereum, the market price of our Ethereum is falling down. So let's say it's fallen to $1.50. As soon as it happens, it means that our collateralization ratio is not 300%, but it's 150%. And if the value of our Ethereum goes lower than that, then the liquidation, the red arrow, might happen. So it means that our collateral could be liquidated. It means that any third party can send transaction to our CDP, to this smart contract, repay our $1 and get $1.50 of value of our collateral. So the economic sense is perfectly understandable why the liquidators are doing it. So we might call them liquidators or keepers in terms of how they are called in the ecosystem of DAI, MakerDAO protocol. But still, the idea is that you pay $1 and get $1.50 of collateral. Why actually the borrower cannot do this? It might happen that dollar spent, actually our borrower spent this $1 for other purposes, lost this dollar, could be anything. So that's the CDP. And around the CDP position, actually a lot of protocols are built. That's how they work. This is the real example from the DAI, the MakerDAO CDP position. What we see here is that it has around 29 million of collateral locked. It issued 8.2 million of DAI of debt. And what we see here is that collateralization ratio is 357%. That's quite healthy one. With the price at that time when I made the screenshot of $2,800 per Ethereum. But here it's not Ethereum, that's another, let's say, liquid staking equivalent of Ethereum. But anyway, we might say that that's the Ethereum for the purpose of our example. And as soon as, and if for some reason our collateral price will go to lower than 1,200 US dollars, then actually the liquidation may start. And what we also see here, that this issuance of DAI is not free. So here the stability fee, so-called, that's in very small letters on the top, is 2 and 25%. So it means APR, its annual rate. So it means that for issuance of this DAI, the borrower pays 202 and 25% interest fee. And if liquidation happens, the liquidity fee of the protocol will be 13%. Liquidation collateralization ratio for the liquidation is 160%. In this example, it's 150. But that's the reason why here we see that our DAI is over collateralized. For the SUSD example, it's even higher. For now, it's 500%. It means that for the value of $5 of collateral, you may get only $1 of the stable coin. So that's a real example of CDP. Actually, the MakerDAO is the protocol, the name of the protocol which issues our stablecoin DAI, and who else is actually working for this ecosystem and takes part in the MakerDAO different functions. First, we have to say that MakerDAO has their own governance token. It's the MKR token, and it is used to vote and make major decisions for the project's development. And what are the key players of the protocol? So we have maintainers, developers, that's who develop our ecosystem, improves the protocol, make some patches, who actually working with the bugs. Then we have oracles. That's also a very important part. So we need to know what are the price of US dollar relatively to our collateral. The keepers, that's those who liquidate our positions which go underwater into the liquidations. And of course, we have some governors, that's the MKL holders who vote for decisions, risk teams who set parameters for our vaults, because someone has to decide what will be the liquidation fee, what will be the interest rate, stability fee, what will be the collateralization ratio, what assets we can accept as collateral, what assets we cannot accept as collateral. So it's all responsibility of the risk teams. And of course, the users, so who actually hold the DAI, and the vault owners who opens these CDP positions and prints DAI. Actually, vault and the CDP, it's the same. It means that as soon as you open the vault, it means that you have a CDP, collateral deposition. Collateralization ratio formula. How do we calculate our collateralization ratio? Again, we calculated it already a few times. We have a certain amount of Ethereum. We have the collateralization price. If we multiply one by another, let's say we have $3 of collateral, and if we print, for example, one DAI, then our collateralization ratio will be 300%. If we print 1.5 DAI, then 3 divided by 1.5, that's 200%. So that's how it's worked. We have to remember that's very simple formula. Now go to the liquidation mechanism, and let's look at how now in DAI example liquidation works. Again, the essence of this liquidation is how at the highest price to sell our collateral to some third party. And in our example, we will look at the specific liquidation which goes with Ethereum collateral, and of course issuance of DAI. And how Dutch auction works. Actually, it starts from some price. With our example, it's $240, and then automatically the price gradually goes down with a certain time frames. It means that the price decreasing, and at any point, and at any point in time, anyone can actually bid for the collateral and pay part of the DAI and receive part of the collateral. Not 100% of the collateral, but maybe just a fraction of it. So when we see that at the price of $195 US, Alice sent a transaction, and what she did, she actually repaid 50,000 DAI of the loan and get 256 Ethereums of collateral. So it means that she didn't repay it in full, because we have here 60,000 DAI loan and 347 Ethereum of collateral. She just partially repaid the loan. That's good. Then the price goes down, and someone else could repay the rest of this position, of this CDP, collateralized debt position. What happens when the price goes to the minimum? Actually, our auction starts over. So it's again, the price is set to 240, and again, price from with the time goes down, and it might have a few loops until we completely repay the loan. So you see that system debt is now 10,000 because we paid 50,000. We still have 10,000 of the loan. So that's it. To continue, what happens if anyway we have we as a protocol have part of the loan which was not repaid by anyone, so no one agreed to get the collateral and repay our loan? That would be the system loss, and actually by the rules of the protocol, the system loss is covered from the DAI reserves, because we understand that our protocol actually earns interest rate, the stability fee, so-called stability fee, for example, 2% and more than 2% for the example I gave you in the previous slides. And what happens is that we actually, as a protocol, collect this DAI in our reserves, and if we have some positions which no one agrees to repay, any keeper, no one wants to do it, so we repay them from our system reserves, decreasing our reserves. So it decreases the profit of the protocol. Next innovation, which allows actually DAI to keep back to $1, is so-called peg security model. What it is, it's smart contract which allows us to exchange a certain amount of DAI for the same amount of other stablecoin. The largest stablecoin to which our DAI is pegged is USDC, and actually it's very much influenced DAI rate when DAI peg, when USDC lost its peg. So everyone understood that for about half, maybe more than 40% of the backing of printed DAI is print with the use of peg security model, and DAI also lost its peg. And what a lot of participants do, they started to print DAI using the peg security model. So when they looked at USDC losing peg, what they started to do, they used PSM to print DAI. It means that they tried to escape USDC, they put USDC into PSM and minted, printed, issued DAI with the same value. So you have 1 million USDC, you put 1 million USDC into PSM, print 1 million DAI, and actually the DAI costs more. So it's like you are trying to save value of your stable coin. That's what happened at that time. And now the system fee is 0, so it's free. But after a certain time, actually when more than 1 billion of DAI was printed in this way, for a few days, maybe day or two, what the protocol, MakerDAO protocol did, they increased the system fee, and it was not free anymore. What happens if you do in the opposite direction? When you put DAI into PSM, you actually, the PSM burns the DAI which it receives and sends to your address USDC. So again, when you put USDC into the PSM, it's kept into the smart contract, and PSM prints you DAI. So in the opposite direction, the PSM burns DAI and releases USDC. So the PSM cannot print USDC; it's only can print and burn DAI. That's it. That's how it works. The PSM statistics, it's here. The debt ceiling at the time I was preparing the presentation, it was 10 billion DAI or US dollars, and it was used for more than 2 billion DAI. We remember that the total supply of DAI is $4.7 billion, so it's more than 40%. Again, GUSD, that's another used stable coin, and USDP, the Paxos USD, it's also almost $500 million US dollars. It's also used. So it means that how much, that's the ceiling. It means that if you want to print, if you have 50 million GUSD, you will not be able to print DAI because of the ceiling. So it's also the job of the risk team, and they set these ceilings, managing the risk of the system. Another innovation from the DAI protocol, which was used by lots of other protocols, is so-called D3M model. It's direct deposit DAI model. This model works with so-called lending protocols. We will also have this topic separately. We'll look at them closer. But to make it simple, the lending protocols, it's so-called the banks of DeFi. So they work like a classical bank. You put the deposit, you take the loan from the protocol. So here, what happens is then, for some reason, let's take an example of Aave protocol or Compound. What might happen is that the rate for the DAI borrowing might be higher than stability fee, which is taken by the protocol itself. Let's have an example. As an example, suppose that, and that's what happens now on the Aave protocol. The rate for the DAI borrowing, it's 5% APR, and the rate of the protocol itself for printing DAI is 2%. Of course, it's make perfect sense for the protocol to print DAI and to send this DAI newly printed specifically to the liquidity pool of lending protocol to decrease the rate. And that's the way D3M is working. It means that when the interest rate of our DAI is in this protocol, lending protocol, is getting above a certain threshold, let's say 3%, 2.5%, the protocol in an automatic way prints DAI and adds this DAI into the protocol, and everyone is happy. The borrowing rates are lower. The protocol earns interest rate for printing additional stable coin, and actually it makes the stable coin, the centralized stable coin, more attractive it increases the number of stablecoins issued. So that's good. And we see here what happened after the D3M was implemented. So the borrow rate for DAI was even 60% at certain periods of time, short, but anyway. And it was like, you know, up and down with great volatility. But after D3M was connected, we see that it decreased below the 10% and didn't get higher. Another very interesting topic, which is also innovation of MakerDAO protocol, is so-called real-world assets collateral. And then we was talking on the previous lecture that that's one of the future trends, which I believe not only I will be the key trend for the crypto in the future. What it means? It means that, let's suppose we have some real estate, commercial real estate in US, and we want to use this real estate as a collateral for a loan. And we see that for some reason, our banking system do not provide us an attractive rate for this loan. And then we may apply to that what happened, that's the real example with MakerDAO, to the centralized protocol, MakerDAO, and say, hey guys, please accept our real estate, commercial real estate as a collateral and give us a loan for a specific collateralization ratio. And then with some the company which is working on behalf of the MakerDAO protocol, we sign an agreement. And what happens then? The collateral now by the agreement is in possession of the protocol, and the protocol MakerDAO prints the loan to the building company, to this real estate company. And then they, let's say, have a few millions of DAI, then convert this DAI into real US dollars and use it as a turnover capital or whatever to build new real estate, commercial real estate, or to use in some for some other purposes. This is the very real RWA, real world assets credit facilities. And what we have here is that Société Générale, that's one of the largest French banks, have this type of real world asset agreement with MakerDAO, and they have debt ceiling. They did have for the time when I took this data, debt ceiling of the $30 million US dollars loan. They've taken just 7 million for, of course, for the volume, for the actually scale of Société Générale. It's peanuts. That's a very small amount, but they are experimenting with the blockchain companies, and that's great. Of course, the collateral, I think that's not real estate in this case. That's some commercial papers or some government bonds, but still the idea is the same. Then it's HVB Bank for 100 million and another company for $500 million, but that's, as far as I understand, investments in the US Treasury. DAI Maker protocol. So our next example is so-called CRV USD, and I propose to go with this protocol on our next lecture. Now, if you have questions, I'm ready to answer. So that's it for today. Thank you for your attention. I'm looking at the questions. Oh, I see. Does the price drop linearly in Dutch auction? How would a liquidator estimate an optimal point of buying the debt? Okay, I'm answering the question. The question is that yes, oh, sorry, the answer is that yes, the price drops linearly. It means that that's actually the algorithm. So no one managing the decreasing of the price. So they are like moving from top to bottom linearly, automatically. Each second or each block, if we talk about blockchain, it's not seconds, it's blocks always. The price goes a little bit lower. How would the liquidator estimate an optimal point? The point here is that the optimal you decided for yourself as a liquidator, because there is a competition of liquidators. If you will not accept a certain price, someone else will do. So it's like you are looking at the price going down at any second. Any other liquidator, they're competing with each other, can come and bid and take repay the loan and take the collateral. So it means that if you will wait for the minimum price, someone else will come and repay all the loan and take the collateral. So you may be left with the zero profit from this liquidation because someone else did it for you. So that's the answer. And can we get these slides downloaded locally? I think the answer is yes. Maybe it's possible to download the presentation as a PDF file. That's what I think. If not, please write us. We will switch on this possibility. So, any more questions? Okay. I hope you understand what actually the CDP is. If not, please ask the question, write down the question, or read about it yourself, because that's the key concept, how DeFi works. You will, in that or another way, meet this type of smart contracts everywhere. Thank you. Kate, please, yes, switch off the recording. We finished.
Okay.